Is it audible? Good.
Good morning, sir.
Okay, but thank you. So, first, I will recall what we have seen in the last class. So, last class, we have seen about the various network devices. For example, suppose we want to expand the LAN. Suppose this is one LAN, this is another LAN. I want to interconnect these two LAN, or I want to expand the number of systems in the LAN. So to interconnect these things, we need the few devices. That is nothing but network devices. We have seen many network devices in the last class. For example, I don't want any intelligence, just only that regenerating of signal is more than sufficient. So I can go for a repeater or hub. So this worked on the physical layer, that is a lower layer. Here, it is like a amplifier. Just it receives the signal, regenerates the signals, then it passes to the next port. But only thing, it flowed all the message, that is the information to all the nodes. So next, due to the technology development, next, the bridges came into picture. Same thing, bridge, it works on purely based on the MAC address or physical address. It is in the data link layer. It works in the data link layer. It receives the informations or messages or packets. It regenerates. Then it passes to the uh, destination node depending upon the MAC address. If the MAC address, if it is present on the another port, it passes. Otherwise, it will stop. It will stop depending upon the lookup table. Then switch. So bridge, it is a two-port network. So advancements of bridge, multi-port network, the switch, it is also work on MAC layer. That is a data link. So data link layer, you can divide that into MAC as well as the logic link control. MAC is physical address. So logical link control, which works on the respective, that checking the logical other things, how the operation is performing, all these things. So even this is also in the layer 2. This is layer 2, this layer 1. So the switch bridges, even it does not have that much of intelligence, because it is forwarding purely based on the MAC address. So if it is the small LAN, then that is very easy to forward the information packets to the destination based on MAC address. If you're interconnecting more than one LAN, then automatically IP address plays the right role, because based on IP address, first you have to identify the respective the LAN, then it will go to the respective end users. So the router came into the picture. It is working on the network layer, that is the third layer, L3. So this router, it will work purely based on both IP address plus MAC address. So the advancements of switch 2, then switch 3, it is also in a network layer. It is a L3. It is an intelligent device. So using switch 3, we can be able to establish the more number of LANs. Only thing, if you take up the switch other things, it is here all that traffic, it is in the local. It allocate dedicated channel, the bandwidth to the respective channels. So this is about the various the network devices which is used to establish, used to expand the LAN. So this class we will see about the LAN bridges. It is in the layer 2. I think this we have seen. Here we can use bridge or we can use the router. So this class we will see about the bridges. Okay. General bridge issues. Already we have seen that. So using bridge, you can be able to interconnect two different segments. You see here, left side it is working purely based on CSMA CD. Right side it is working based on the token thing. So only thing, even if you take CSMACD, the MAC address different format. You see the token ring MAC address different format. So only the issue with the bridge, it has to deal with different MAC formats, different rate, different buffering, different timer. Because CSMACD it is having different features, characteristics. Token it is having different characteristics. So it should work purely based on both. Similarly, the frame length. It is having different frame length, it is a different frame length. So only the issues with the bridge, it has to deal with different MAC format, different the data segments. So I think this is normal thing. Okay. If you see here, all that the network, it is having multiple layers. But MAC, that is bridge, it will work only up to the MAC layer. This is the combination of logical link. MAC, it is nothing but the data link layer. So in the data link layer also, it works only on the lower level, only on the MAC. So it works only up to that that lower, that is the layer one, then half of the layer two. That is the problem with the bridges. So it does not have that much of intelligence. So the types of bridge, it is having two. One is nothing but transparent bridge. Next is the source routing bridge. The transparent bridge, it is used in Ethernet LANs. In the transparent, it is a remote. So does not know anything about which one is the respective the respective destinations. Source routing, it know all that route from source to destinations. So we will see about the transparent bridge. So the transparent bridge, let us consider. So we want to establish the connections between LAN 1 to LAN 2. I am connecting this bridge. So the IEEE, it is in the standard. They used to define the standard for most of the technical devices. Institute of Electrical and Electronics Engineering. It is the non-profit organization, and there they used to define the format for each and every devices. So they define the transfer bridge is defined by 802.1 D committee. So here, its standard includes bridging spanning tree. So the spanning tree we will see in the next class. The major performance, let us consider if I want to pass the information, the frames from S1 to S6. The bridge will forward frame from one LAN to another LAN. It learns the location of the stations in the LAN, because now starting stage bridge is an empty. Only by means of that learning, during initial process, it learns the respective the station address. It learns, then it passes. It prevents the loop in the topology. So what is the looping, how it is occurring, that we will see in the forthcoming slides. This is the three major functions. It forwards the frame, it learns that location of the stations and update the forwarding table, it prevents the loops. So it uses lookup table, that forwarding table. It discard the frame if the source and destination in the same LAN, because that bridge will, this is this is port 1, port 2. Bridge will update the forward table or lookup table if the both source and destinations address in the same LAN, that is in the bridge port 1, it will discard, because no need for sending the frames, because destination is also presenting on the same LAN, no need for forwarding here. It will discard, it will resend to the respective LAN. If the both the source and destination, suppose I want to send from S1 to S6, both are in the different LAN, now it will forward. So use floating if destination is unknown. Before updating lookup table, suppose the S6 is not in the table, it will float to all. It will float to the same LAN. It will float to the all the LAN. Once if it is finding the respective destinations, it update the lookup table. Next time it is same thing happening. simply it will forward to the respective LAN. So it used backward learning to build a table. Depending upon the respective, during the flooding, it will identify the destination address. Then automatically, it will update it will build the lookup table. We will see with an example. So now, to update the lookup table, bridge should learn how the bridge is learning. So the frame arrives on one port of its port, or that is one of its ports. The bridge just has to decide whether it had to forward or not. So depending upon the table, the values in the forwarding table, it will forward if the both the station in the same thing. If it is on the same port number, same the bridge port number, no need for forwarding. So that the forwarding table we can fill in the two way. One is nothing but manually. So network administrator can record the station address. For example, here. So here they can the build like that. So the S1 it is connected to the port 1, S2 port 1, S3 port 1, S4 it is connected to the port 2, S5 port 2, S6 port 2. This is nothing but a forward table. It contains the respective the station plus the respective the bridge port address. So here we can do manually also, but if the number of the system is less in the LAN, we can go for manually. But if it is number of system is very high, it is very tough to fill the table manually. So the disadvantage, the entry has to done manually. When bridge receives the frame, it compares the source address of the frame with each address. If the address is not found, it forward. Otherwise, it will this thing. If it will discard. It will discard. Match is found, it will forward to the indicated. If it's not found, it will the float. It will float. Then it will update the respective tables. For example, let us consider three LAN which is connected by use of the two bridge. So this is then the forward table or the lookup table at the bridge 1. This is at the bridge 2. So we may ask the problem like this. You kindly carefully listen the problem. It is very easy only. Very easy only. So the two systems nodes are connected with the LAN 1. One is at the LAN 2. 2 is at the LAN 3. So each LAN is interconnected with the bridge. First, that both the lookup table is empty. The first condition, S1 sends the frame to S5. Now this is source, this is destination. S1 sends the frame to S5. This is the first case. Now S1 sends the frame to S5. It reaches the respective port 1 of bridge 1. Now it is a fresh. It does not have any information about the S5. Simply it flowed. This is the meaning for flow. Does not know where S5 is located. It will go here. Here also it is empty. It will flow. So the first stage, S1 to S5, it reaches here. Now it checks the respective lookup table. Address is not there. It is floating. But meanwhile, it is updating the address. So S1, it enters to the bridge 1 through port 1. So port 1. S1 port 1. S1 port 1. Because S1, it is the known address to us. S5, we does not know whether it is existing or not, also does not know. So S1 is only the known address. So it updates the known address. So S1, it enters to this B1 through port 1. Now it is floating. It is moving here. Now for the B2 also, it is reaching through this point. It is floating. Meanwhile, it updates the address that S1 it is entering through port 1 for the bridge 2. Bridge 2. Yeah, S1 is entering through port 1 to the bridge the 2. Now it is, it is transmitting the respective frames. Now during this first case, both the bridge it understand that. So the respective S1 address it is existing at the port 1 of bridge 1. Similarly, the port 1. Any doubts? Shall we move? Okay. So similarly, if time is 8:35, anyone can inform to me because I am not having now the mobile at present with me. If anyone kindly note down. If time is 8:35, you can kindly inform to me. Okay. So this is the first case. So next, the case 2. S3 to S2. Now this is source. This is destination. So S3 to S2. It will go here. Also, it will go here. If it is reaches here, so this B2 bridge, it contains only address about the S1. Similarly, the bridge 1 is also, it contains only address of the S1. So both will float the frames, float the frames. Then it will update. It will update. So S3, it enters to the B2 through port 1. S3 enters to the B2 through port 1. So it flowed the message. Here in the bridge 1 also, S3 enters the bridge 1 through port 2. So S3 port 2. Now it flowed, it flowed, it flowed. Then it transmit. So that has been received by S2. Now everything was over. It floats here. It does not match anything. So it has been discarded. It has been discarded. Now using these second conditions, both the table has been updated. The next address of the next stations. This is case 2. Case 3. Third scenario. S4 wants to send a frame to S3. Now this is source. This is destination. S4. It will come here. It will come here. So now S4 reaches at the B2. So the destination address is S4, receiving is the source is S4, destination S3. Now it search the lookup table. S3 is present at the port 1. So now it is forwarding. And it updates the table. S4 reaches the B2 through port 2. S4 reaches B2 through port 2. Now it looks the forwarding table. S3 is at the port 1, so it is forwarding here. So now the packets in frame is moving here. It will go in this directions. It will go in this directions. Now it receives S3. Meanwhile, S4, S3, it reaches here. It check the lookup table. So S4 is not present. So it updates. S4 reaches through port 2. Now it check X3. S3 also it is reaches through port 2 from the lookup table. So both S3, S4 on the same port. So it will discard the frame. Now if you see here, in the previous cases, simply it flowed the frames. Here it forward at the B2, it discard at the B1, because both S3, S4, it occurs, it enters at the same port of B1, it discards. In the B2, the S4 is entering through 2, S3 is at the one, so it forward. So this is the third example. It will discard. Yeah. So next, S2 to S1. This is source. This is destination. S2 to S1. Now, if you see here, it is reaches here. It updates S2 reaching through port 1. Now it checks the respective lookup table. S1 already it is there in a port 1. S1 it is there in the port 1. It discard, it won't pass, it discard, it will again routed back here to the S2. Now if you see here, it won't pass us to B1 to B2 because so both S1 it is occurring on the same port of the bridge 1. It checks the lookup table, then it discards. Update only S2 1, it discards. So now if you see here, mostly that that discard is happening already. It almost it updates the lookup table. So this is nothing but updating lookup table for a transparent bridge. So we may ask maybe one problem in a cat one. So I will give that example problem also at the end of this class. I will upload on the beta. You can try it. Any doubt here? Shall we go to next one?
Yes, sir.
Okay, thank you. Now, if you see here, it is an adaptive learning. This adaptive learning. So it it learn by the respective bridge itself. For example, sometimes in the lookup table. So we are not having any the frames for S3 port 2. So unnecessarily, keeping this lookup table for long time, it won't be good because the reason is sometimes S3 may be in the fault. So the bridge does not know about anything, whether that the respective node is connected or not. So now the keeping S32 for a longer time, it is the wastage of the resource utilization. So we are fixing the timer. Then we are starting that reset timer. If it reaches 0 automatically, that means for example 30, let us consider we are fixing as maybe 30 minutes. So for the 30 minutes there won't be any response from S3. Automatically bridge understand that S3 is the faulty conditions. We may remove this S32 entry from the bridge. So this is nothing but the adaptive things. So the loop problems, the third functions we have seen that it avoids the looping. How the looping will be happening? For example, take this. So to interconnect two LAN, one bridge is more than sufficient. But as the administrator, I may add one more bridge also. The reason, suppose the bridge itself, it is in the trouble, it is in the repair. Automatically, so the connecting LAN 1 to LAN 3 entire service will go down. So to overcome that, mostly the network administrator will have one more bridge which will interconnect L1 to L2. It repeats the respective operation of the function of B1 if B1 failures. Because always any network administrator service provider should provide that um, uh, without any interference, they should provide service to the end users. Always they used to keep the additional bridge that is called as the redundant bridge. Due to this additional bridge, looping will happen. We will check how it is working. For example, so LAN 1, LAN 2. So between LAN 1 to LAN 2, we are connecting two bridge. Now, station A sends frame to station D. Now, as per transparent bridge, the principle, so now both will come here. The frames will come here. Since it is floating. So storing during the initial stage, only it update address of the A. A is reaching at port 1. A is reaching at port 2. It does not have anything about D. It float. It reaches here. It will go in both the directions. This will also go in both the directions. Now it will come here because it is having two copies. So this will again go here. It is coming through here. Again, it may go here since it is floating. So now this is copy 1. This is copy 2 at the LAN 1. So now LAN 1 also having two copies. Again, it will passes. It is coming here. Again, it will go here. It will come here. Again, go here. Now this creates looping problem. Always that the two copies will float between LAN 1 to LAN 2. This is the looping problems. If you are using two bridges automatically for the interconnection of the same LAN, so the looping problem will be happening. We should avoid the looping problem. The reason, if looping problem is happening, so both bridge 1, bridge 2, always it passes only this frame. So if any other frame is coming, it should wait. It will reduce the performance of a systems. So the process continues. Then note the bridges also repeaters regenerates frames. So in each iterations there are newly generated fresh copies. Each and every time it generates the fresh copies. Ultimately, so more number of that duplications will be producing there. It will leads to the looping. It will leads to the performance reduction of the bridges. So if you see here, same thing, redundant. It is coming here, it is going here, coming here. So if you see here, this is the redundant link. So automatically, if you are going for these things, that the looping, automatically it will trigger the next frame floating, causing the broadcast stop. You cannot able to go for the broadcasting more frames. To reduce the looping, to avoid the looping, so we are going for the spanning tree algorithm. It is an algorithm which is used to avoid the respective the looping. For example, between LAN 1 to LAN 2, two bridges are connected without any the proper methodology. If you are going for transmissions, so here looping problem will come. So this will reduce the network performance, the bridge performance. To overcome this looping, we are going for a spanning tree algorithm. So this spanning tree algorithm, problem on spanning tree, we will see in the next class. This is another example. So the same like the previous case, 5 stations are connected. You kindly update the forwarding table. I will upload this in the Vita. You kindly update the forwarding table for bridge 1, for bridge 2. Any doubt? So this class we have seen about what is the transparent bridge. The function of transparent bridge, it does 3 operations. One is nothing but it checks the forwarding table. If both the frames are in the same port, it will stop, it will stop the forwarding. It will again resend to the same LAN. If both the frames are in the different port, both the address stations, it will forward. If destination is not found on the for lookup table, it will float. It will float to the entire LAN. Similarly, it will avoid the loops in the respective the LAN by using the spanning tree algorithms. I will upload this also in the VTOP. You can refer it.